Welcome to our new series, 20 Minutes of Tech. So our subject matter today is fever detection using infrared cameras. So there we go. So I'm your presenter, Randy Montelius. I'm the VP of Technology here at CEC. My role is to help CEC bring the best technologies to our customers and to help them implement them in great ways. So now that you know just a little bit about me, let's get started into the subject. So I guess before we start about infrared, it'd be certainly worthwhile talking about, what is IR? So IR, and by the way, I'm not a scientist, but I can talk a little bit on the subject, so let's dive in. IR stands for infrared radiation, which is in fact light. Now, infrared light is emitted by all heat sources, including people. So all people are emitting some form of infrared, we just can't see it. Now the infrared is just above the red spectrum in the light scale. So again, not visible to the human eye. So, however, infrared light can be seen on a camera, IR specific cameras with the right filters, and that light can be displayed on a monitor, which is how these systems basically work in a nutshell. Now the wavelength of that infrared light that's emitted is an indicator of the object's temperature. So the infrared camera can be used to measure the relative temperature of objects using that light. So, and the thing is, infrared cameras are not new. This technology has actually been in use for several years. Some of the uses are, excuse me, some of the uses are for energy efficiency. So like in the picture in the lower left-hand side of the slide, you'll see that there's a infrared imager being used to check where heat is leaking from this home. And that would be used, of course, for, shoring up insulation and things such as that. So that's a pretty common use. Obviously, the accuracy needed for something like that is relatively low. The other way that infrared camera technology is used is on perimeter security detection, where in a dark or not very well lit environment, you'd be able to see people, animals, things that emit IR light or heat. You'd be able to see them very well using this type of camera technology. Certainly used in the military, certainly used in high security type perimeter applications. A third area also where this technology has been used in the past is really in the industrial applications, where you might be watching let's say a motor or a gear or things such as that, where heat was critical, and you'd be able to tell when things got hot without having to go out there and measure it specifically. You could see it from a distance using infrared technology. Now, although those are common uses, they're not common uses in terms of frequency, of course. So because of that, these cameras were always considered a specialty item, and therefore the volume of sales on these products were pretty much low compared to standard cameras, which was the bulk of most camera manufacturers' business. But then the pandemic came along and things changed. So now we've got a situation where organizations are wanting to screen their employees and their visitors before they enter the facility. Consider that for a manufacturing plant, the cost of shutting down that plant, even for a day or two, could run them millions of dollars in terms of lost production revenue. Public and retail spaces want to assure that they are providing a safe environment for their visitors so that they can attract more foot traffic. So because of all this, a lot of the IR camera manufacturers are now swamped. I heard a rumor that one of the manufacturers has already received in 1 month more orders than it did all of last year for its camera technology. So because of that, you've got a situation where a lot of these manufacturers are just overloaded with orders. Some of them have decided that they're going to prioritize hospitals and healthcare customers and provide product to them first, which kind of leaves non-medical customers experiencing delays in getting product. So the other thing I would consider is that, at some point this pandemic is going to end, but I would suggest that perhaps some of this is going to linger. This could become the new normal, especially in private businesses, as they want to continue to make sure that they're doing everything they can to make sure that they're providing a safe space, a safe environment, and that there's no recurrences of this or some other fever-related item. So anyway, that's the situation as we currently stand today. So things have changed quite a bit. So let's dive into a little bit about what we're really doing with this technology, or what the goal is. So the goal is really fever detection. However, what we're really measuring is elevated body temperature, also described as EBT. You'll hear it coined as that quite a bit. Now, infrared cameras are a great way to do this because they offer this contactless, non-invasive way of measuring the body temperature. However, elevated body temperature is just one of the symptoms of fever, but elevated body temperature could be caused by other factors, the environment, exertion, things such as that. So when you measure this, you can't really be certain that, this is fever related. So, but this is a good first step. It's a good screening technique, okay? So if elevated body temperature is present, what you really need to do is then move to a secondary evaluation, a more precise evaluation specific to fever. And we'll touch on that here in a little bit. So, whoops, sorry, I went back. So the next slide then is has to do with the accuracy. Accuracy by far is the most important factor when deploying infrared cameras. If you don't have good accuracy, you're going to get a lot of false reads. You're going to have upset employees, upset customers. So, trying to zone in on that and have a highly effective solution is pretty important. However, the accuracy of these cameras are affected by a number of things. It's affected by distance to the subject. It's affected by the resolution of the camera. It's also affected by the location on the body where the measurement might be taken. So I've been looking at this here recently as these types of technology have been kind of flooding the market here lately. And I've been seeing what appear to be some exaggerated claims. For instance, the ad that I've clipped here that's on the PowerPoint shows a number of people exiting some mass transit, okay? Now, if you looked at this ad, you'd get the impression that you're going to be able to get a precise measurement on multiple moving subjects at varying distances up to 1/10 of 1 degree accuracy. So from my research on this, that seems like it's somewhat unlikely to be achieved here. So I would say be careful on some of the claims out there. It's certainly a great technology and has a lot of promise, a lot of capability, but your setup will determine how accurate of a situation you're going to have, right? Results may vary. So jumping into the setup then, let's talk about some of the factors on accuracy. So, because this is more complicated than just installing a camera. So the ideal setup would be to have all subjects stop momentarily at a consistent distance from the camera to get an accurate measurement. So, and ideally, setting up like this, you'd be able to set up a screening station where visitors and employees would actually come through your screening station and then move on once they pass. Now, when you set up this type of a deal, the screening typically could take up to 5 seconds per screening. And, the subjects that registered an elevated body temperature, you then want to discreetly direct them to a more private area for, that secondary evaluation. The other thing that you'll find quite frequently, but isn't brought up a lot, is often to get the accuracy that some of these devices are claiming, you need to add a fixed heat source. And that fixed heat source is also called a black body emitter. And that is a very precise instrument that you would put in the scene with the video, and it would produce that fixed temperature at, say, 98.6, and it allows that visual reference for the camera to be able to compare the reading of the subject against that. And that really has a large effect on the accuracy of these systems. As a matter of fact, a lot of times without that, they can't achieve the accuracy that you might read in the specifications. So the other, or another area, or another factor that is relevant in terms of the accuracy is the measurement location. You know, these infrared cameras measure the surface temperature. And of course, the forehead is susceptible to, you know, cold, hot, things like that. So, you know, imagine an employee that is coming in from a very cold outdoor temperature, gets inside, and you go through the IR. Chances are that's gonna impact the measurement. The better method is to measure at the tear duct. In medical terms, that's called the inner canthus. And I'm no doctor, so I'll stick with the tear duct reference. But if you notice the infrared image of the person's face on my screen, you'll see that the color variation, and therefore the temperature of the face, it varies quite a bit, especially on the sides where it's really quite a ways off from the true inner body temperature. But you'll find that the tear ducts are probably more closely aligned to the inner body temperature. Therefore, it's a great area to produce those measurements from. So as a matter of fact, the cameras that measure at the inner canthus and use a fixed temperature emitter typically will call out accuracy of plus or minus 1/2 of 1 degree Fahrenheit. And so that's pretty good. That, I think, would be pretty consistent to be able to determine whether somebody might have a fever or not. Now, of course, when you're measuring the tear duct, that does require that they're going to have to remove their eyeglasses. Eyeglasses will many times block IR, so you won't get a true meaning unless that occurs. But so that'll be something to consider there. So moving on a little bit here into some of the governing bodies, you always have to consider, you know, the FDA. And the FDA, Food and Drug Administration, governs all medical instruments. Now, in the past, in the previous uses of these IR cameras, they weren't really medical instruments. So FDA really didn't have you know, much governance or much say in the matter. However, they have come out recently with some guidance and stated that, hey, cameras that detect human body temperature may be considered medical device and may fall under their jurisdiction. Well, it's just like a government agency to be supremely vague in that matter, isn't it? So, however, they did release some guidance that says during the pandemic, the FDA is relaxing the regulations on these devices. However, as part of this guidance, the FDA does recommend certain things happen. Number one, they recommend that the infrared camera measurement should not be the sole or primary source of diagnosing COVID-19 or any other disease for that matter. They want that to be only a pre-screening situation. Secondly, they also suggest that any elevated body temperature must be confirmed with a secondary evaluation method, such as a clinical grade contact thermometer. So anybody who doesn't pass that initial screening needs to be moved to a secondary evaluation area, and that secondary evaluation needs to be performed. And then thirdly, their FDA recommends that this technology should only measure one subject at a time. So think back to that scenario of everybody leaving mass transit and trying to measure multiple subjects at once. Not recommended per FDA. Another thing to keep in mind is that the FDA may reinstate some of their regulatory requirements post-pandemic. However, we'll have to wait and see how that pans out. So, and then one last thing to consider is taking someone's temperature borders on that private health information, and therefore any companies or organizations needs to consider, the employee or customer privacy issues related to, notice, capture, storage of such data. That's certainly an area where the relevant work needs to be done to make sure that we're following all the FDA guidelines and such. So with that, let's dive into some of the actual technology itself and take a look at what we have here. So I would say starting off at an entry level, you've got the handheld thermal imagers, which I've got on the left. These are, lower resolution infrared cameras kind of on a stick, okay? So they're a little bit lower price point, around $5,000 to $12,000 to get the ones that are intended for body temperature measurements. Certainly there are others, and I've seen some at a lot lower cost. I just haven't been able to find where those are actually recommended for the purpose of measuring body temperatures. So that's one area. Although it's for lower cost, it requires an operator for each one of these units, of course. So the labor portion of deployment on this is going to be higher. It also means that the person is going to be in closer contact to the subject every time they perform one of these measurements. So what's probably we're seeing the most interest in is these fixed mounted cameras. You see the one there in the middle. It's a camera with two different lenses, one IR, one regular camera. So you can see both the real-time view of the subject and the infrared view simultaneously. It's also in more of that fixed mounting, and the people can walk through that screening station. Now, these types of systems typically run between, let's say, $15,000 to $30,000 per station once you get them all set up, once you include the fixed temperature device and things such as that. So that's approximately where you're looking at on that range. And then more recently we've seen a newer one, which is what I would call the self-service kiosk. Now these they're more of the $5,000 to $10,000 price point. They're tablet-based. They've got a lower accuracy camera attached to them, but I could still see where if you wanted to do kind of a self-service kiosk setup where you had multiples of these, you could set them up and have employees or visitors come up and almost register themselves or take their temperature. And, if they did, exhibit EBT, you'd want to, divert them to a different area for that secondary screening, of course. But, I could see this setup. It kind of reminds me of the self-checkout at Target, right? It's kind of a do-it-yourself deal. But I could see that gaining steam, especially because in high volume situations where you've got to put a lot of people through an area, this might be a way to go and to be able to afford multiple stations, knowing, of course, that you're going to have a little bit less accuracy. As a matter of fact, the accuracy on these are more in the 1 degree. So these could vary by 1 degree plus or minus. So you have to weigh the fact, is that good enough? Knowing that you're going to have more false positives in a situation like that. So, but something to consider. And there is one last area that we found. There are some what I would call medical grade systems. They come on rolling carts. They're really made for the hospital environments, and they can do some really sophisticated stuff. I would say that those are probably beyond the scope of this application. The one advantage that they have is they're all FDA approved with the, the 510K certification, and therefore, you'd have no issue with the FDA in that. However, it's just probably not the right scenario. There are some a small set of cameras that go on the tripod that do carry that FDA clearance, and so those are the ones that are typically at that $30,000 price point. So now that we've gone through the product and some of the things, let's talk about how, in practice, what the ideal situation would be. Certainly, knowing what we know now, you'd want to have that stop and scan configuration. Again, it would slow down that throughput, but you're going to gain accuracy there. You may need multiple lanes depending upon how many people are flowing through that entrance. You also, of course, need to have them remove the eyewear. And then you need to set up that secondary testing station. And here's where I think some of the non-technical factors come into play. As a matter of fact, I would invite you to consider that if someone did, register elevated body temperature, I would want to kind of, without causing a lot of attention, I would want to divert them. Maybe they're handed a card, and on that card it says, please proceed to this area, and I would look for that area to be private so that other people don't see who's being directed to that other area and see them getting their temperature taken. I would also suggest that once they get there, they're explained, why they've been asked to go there. They've been exhibited elevated body temperature, and that there's a consent form or sign-off sheet, something that would protect you in terms of that. And then I would also suggest that, way before they get in line, that there's the proper signage out there that body temperature will be taking to gain entrance. I would say that if there's somebody who just fundamentally doesn't agree with this or doesn't want to submit to this, they should have the opportunity to opt out of this before they get in line, before they potentially cause, a scene or anything like that. Let's give them that choice early on. So. And some other considerations in terms of, laying out these types of solutions would be the number of entrances. I know a lot of you probably have many entrances. You may need to consolidate those. And by consolidating them, you could set up this for people who enter, and then maybe people can exit out the others, but you're gonna restrict flow of traffic to those areas. So you're also going to want to think about the space. Even though people are coming through, we may still be asked to practice social distancing for some time. So do you have the area set up to where people can go through and still practice that social distancing? And then consider those aspects of personal health information and the duty of care that's expected of you when you take someone's temperature and what happens to that information. And then, of course, you'd have to weigh the overall investment of deploying something like this versus the cost of having to shut down your facility, or the cost of turning away potential customers, and what would be the effect that would have on your organization. So if you are considering IR cameras and would like to discuss your options with us, please feel free, to contact us. We'd be happy to help you out. We've got many years of experience in the security camera market, and although infrared is a little bit different technology, it's really the same manufacturers that are producing that, and we've got a lot of good information and resources to help you deploy that. And not only deploy it, we can, if necessary, integrate it into your existing video security platform. So with that, that's the end of my presentation for today. I really appreciate you all joining me, and please join us again for a future seminar of 20 Minutes of Tech. Thanks so much.